Okay, welcome back, everybody. So now we've introduced ourselves to each other, and we've had um, a little bit of talk about the fundamentals of what we're going to do. Now we're going to talk about some case studies that we have explored that kind of look at the intersection of what we can do with archaeological data and AI techniques to look at them. So basically, what we're looking at here are ways to sort of reconstruct the rules of games, but also to use what we know of the rules of games to study other kinds of aspects of games and explore archaeological questions. So I kind of already talked about earlier, what we have to do is identify what it is that we actually know, fill in the holes of what we know from other games that are similar either in gameplay or in chronological or geographical origin, um, place those into the holes of what we know about the games, use AI playout simulation to analyze these Frankenstein versions of these games, if you will, evaluate those games with different metrics, and identify rule sets based on those playouts that kind of fit with the historical record or the evidence that we are dealing with. So our first case study deals with identifying whether certain boards belong to particular games that we know about from the archaeological record. And thank you, Tim and Soemers, for the photo here of these games that we will talk about. And this is, again, Ludus Trunculorum, which we talked about a little bit earlier. So as I mentioned, it's a Roman game that we know quite a lot about in comparison to other ancient games. And I talked a little bit about it before, but just to recap, what we know about this game is that it was played on a rectangular or square board, that the movement is orthogonal, meaning it moves vertically or horizontally along the grid, that it has this mechanism called custodial capture, where you surround a piece on both sides and capture the one in the middle, and that there is a placement phase to the game. So the pieces start off the board, and you start the game by putting them on the board, and then you move the pieces afterwards. So archaeologists, knowing this, have found a lot of square or rectangular boards at Roman sites throughout Europe and North Africa and Western Asia, and have always said, okay, well, this is a square board, a rectangular board, Salutis Trunculorum, because it's Roman. But what's weird about it is that these kinds of boards exist in many different sizes throughout the empire. So you have them from as small as 6x6 up to and even just outside the empire as well, which we know the Romans were interacting with the peoples outside the empire. But they go up to as big as 18 by 18. Looking at our database and from the experience of gathering all this data about games from around the world, this is a very unusually big range of board sizes for one particular game. So we wanted to explore the question of whether all of these boards really make sense for this game based on the rules that we know from ancient Rome. So here is a kind of a distribution of the game boards that have been found, with colors kind of representing the size. The yellows and oranges are the smaller boards. The blues and purples are the bigger ones. And what you can kind of see from this distribution already is that a lot of the bluer and purple ones are kind of, for those of us who are not archaeologists, borders of the empire are about like this. It goes along the Rhine and the Danube in Europe, basically, and then up to Scotland and Britain. So the blues and purples tend to be on the outside or around the edges or beyond the limits of the empire, whereas most of the ones in the core, really the urban core of the empire in Italy and Anatolia especially, are the smaller boards. So this is already raising questions of, and all the people that are writing about the boards should be, it's important to note, are writing from Rome. So those are the games that they would be familiar with. So what we did was we looked at looked into our database to look at what other games we have that have these different the movement and the rules that we know from the ancient sources. So we looked at the games that have the custodial capture mechanism, that have orthogonal direction of movement, that have the square-shaped board and the square tiling. So the shape of the board itself is that this is the square, and the tiling is that it's made up of squares. And then the pieces are placed outside of the board at the beginning. And what we found were basically these 5 games that have all of these different features. And so the idea was we were going to pick the rules from a couple of these games, put them on the different board sizes that we know were found at Roman era sites, and see how they played. But to find which of these we should choose, if we look at kind of the geographical distribution of them, only 2 of them, these 2, this game here, we actually had discovered after we did the analysis, but it's basically the same as these 2. These are the only 2 that were within what used to be the Roman Empire. The other 2 are pretty distant from them. So what are these games? Siga and Karebga. Basically, these are games that are played on usually a 5x5 or 5x7. Siga has also a 9x9 size board. You place your pieces 2 at a time. The pieces per player are that equation. So basically, once the board is filled, there's 1 spot left available. Once all the pieces are placed on the board, you move orthogonally. The difference between the 2 games is that Siga, you move 1 step at a time. In Karebga, you move, we call it the slide move. It's like a rook in chess. They both have custodial capture. The player who captures all of the opponent's pieces wins. And we know that it's been played at least since the 19th century. This is kind of a grainy photo of drone footage from the top of the Great Pyramid in Egypt. But this is a much later game. It's not an ancient Egyptian game. You can see Irene here. She's not an ancient Egyptian. It was probably played by the Egyptian guides that would bring European tourists up to the top of the pyramids when that was still legal. Don't try to do that now. So yeah, so we know that it existed in Egypt, at least in the 19th century. Karebga was from Tunisia, actually. So we're not trying to say that these are necessarily the versions of the Roman game, but these are the games that people have played that are most similar to what we know of the Roman game. Already, we run into some problems in trying to place these games from those boards, the rules from those games onto these boards. So according to what the data set that we had, of all the boards that we found, none of the Roman boards have a central space on them. So all of the ones so for Siga and Karebga, they're 5x5, 7x7, 9x9. That geometry leaves a central space open, which is the one that you have to leave open when you're placing the pieces. But the Roman boards don't have that because they all have an even number of spaces. So that's already something interesting that's going on there. So we had to calculate the number of pieces a little bit differently and leave 2 open spaces when we applied them to this board. And we allowed the empty space to be anywhere. And that also leaves at the end of the placement phase only 1 piece per player, so they only place 1 at the end. So, and then just for fun, we also analyzed the game of Tablut in this data set. So this is a game that was played among the Sami people in northern Sweden. It's thought to be the descendant of Viking Hnefatafl. It was documented in the early 18th century. It has a lot of different rules from the Roman board, but it does, from what we understand from the Romans, but it does have that custodial capture mechanism, which is quite uncommon in traditional games. So we included it. And also, it also has from Hnefatafl has varying board sizes. So we also applied it to boards, but we ran into problems of also when we increase the size of the board, what do we do? How do we add pieces to it? And so we had a couple of different options. Either you keep the same number of pieces, or we add more pieces in a proportional pattern to what was documented. So we put the rules on those different boards and ran playout simulation experiments. So we applied them to those in Ludi, actually Ludus Atroculorum, and the Poprad game, which is the big one, which is either 17 by 18 or 18 by 18. There are two different games in Ludi, but we use the rule sets on both of them. We had the AIs play them 100 times per each rule set and board combination, with a maximum number of turns of 2,500, because as we've kind of mentioned, AIs are not like humans, and they will play forever and ever if you let them. So I will hand over to Dennis to talk about the AI aspects of this.
Okay, yeah, so there are two relatively basic AI approaches that we use to control these players. So one of them is called UCT. Thank you, Levante, for giving us this algorithm, and the other alpha beta search. So relatively simple AIs compared to the famous ones that are going around nowadays with deep learning and for like AlphaGo and this sort of stuff, right? Relatively simple search algorithms. Pictures of them and those details are not really relevant, so I'm not gonna get into those. Yeah, and both of them had some issues on these Ludus Atroculorum games, and especially the versions with the big boards, right? The big boards went up to like 18 by 18 for a game that, like, yeah, so Go is a common game that has a 19 by 19 board, right? But Go doesn't involve moving pieces. It's just placing stones. And also Go actually is quite a complex game for AI, right? But this is even, imagine this big 18 by 18 board filled with pieces that can all like slide or step around. For AI, this is a really difficult game to actually reach a meaningful end. And so these games, they don't naturally, if you start playing kind of randomly, they don't naturally converge to an end. Because in these games, I think the win condition is you have to capture all opposing pieces. If you have a huge board filled with pieces and they can all slide or step around, under random play, that game's never gonna end. And UCT is an algorithm that's partially based on this random play. And from random play, it will figure out, okay, how should I be playing? But so this UCT algorithm itself on these games, especially on the big boards, it plays pretty much randomly. Alpha beta is intelligent, but with respect to a short horizon. So it can look like 4 steps ahead. And within those 4 steps, it will try to minimize how many of my pieces are getting captured and how many of the opposing pieces can I capture. Yeah, so at least that one can be a bit better than random, but up to a relatively short time horizon. So when we do this UCT versus UCT, it's basically equivalent to doing random versus random, except you waste a lot more computation time. When we do alpha beta versus UCT, this alpha beta does actually look far enough ahead that it can exploit its very bad UCT player. So alpha beta will dominate. And with alpha beta versus alpha beta, the game basically never ends, because also the capturing is complicated. You don't capture by just landing on top of a piece. No, you actually need to squash a piece between 2 others. You already need to really think multiple steps ahead for that. And on this huge board with so many pieces, the AI doesn't manage to think ahead very far unless you have a very, very big computer, which we don't have. So this is kind of how these different AIs behaved. Except with the alpha beta, we could do a nice trick. So this alpha beta algorithm, which is basically based on this minimax that I explained earlier, right? That it really searches this kind of triangle that thinks ahead a few steps, like what can I do? What can my opponents do? How can I respond to that, etc. You have, in this algorithm, you have this effect that we call the odd-even effect. where if you search to an odd depth, so here to depth 1, for example, you're just looking at what actions can I do, but you're not looking at what are my opponent's responses. So for depth 1, you just look at what can I do, and then from that you evaluate. If you do that at depth 1, in your brain, right, while you're thinking this one step ahead, you didn't give your opponent a chance to respond to the move you made. So that typically results in an aggressively playing AI, because you see, oh, I can make a capture, and you don't think about how your opponent could respond to your capture. So an odd search depth, you get the same if you search to depth 3, you get the same if you search to depth 5. You always, in your thinking process, you made the last move. You didn't let your opponent respond to your last move. So that typically gives an aggressive player. And if you search to an even depth, you get the opposite effect where your opponent got the last move. So if you search to an even depth, you typically get a kind of defensive player. So what we also tried is 2 alpha beta players, which search to approximately the same depth, which usually means approximately similar playing strength. But we told one of them you can only search to odd depths, and the other you can only search to even depths. So you get 2 players who are roughly equally strong, but they have different kind of personalities, right? One of them is aggressive, one of them is defensive. Maybe I don't want to say this too much out loud, but maybe that's even slightly more human, that the human experience, and that humans, they're probably not exactly the same, right? Humans are not, if human players are playing the game, you don't have 2 copies of the same human. One of them is probably a bit more aggressive and the other is probably a bit more defensive, or one is just a bit more skilled than the other. It's never 2 copies of the same human playing, right? That's a very dangerous argument to make, but at least at least this did give better results than just this never-ending situation. Because if we didn't do these 2 personalities, they also, what we talked about earlier, the etiquette, right? They couldn't find opportunities to win, but they could definitely find opportunities not to lose just by moving back and forth between the same spaces over and over again. And with this aggressive versus defensive AI, that didn't happen. Games actually did end. Yeah, so that's one of the extra experiments that we ran. This is you again, right?
Yeah, it's me. So a couple of things that we looked at, or well, one of the things we looked at was the completion, which is a metric that can be calculated in Booty, which is the percent of the games that were played until the winning condition was met, so that all of the pieces were captured. And you can see the blue pieces are with the Sega rules, at the one where you move step by step. The orange ones are the Crist games where you can move like a rook. And then the tableau, it only really worked to apply those to the 17 by 17 board because you needed the central space. So as you see, as the board size grows, the Sega games are not being played to completion. And in fact, once you get to the really big ones, it could never finish the game. Whereas Karebga with the slide rule, it completed more of them. It did decrease as the board got bigger, but it was able to be played more. This is kind of obvious, right? If you're only able to move one space at a time, that's gonna make things more difficult to end. And so we also measured the duration of the game, which is kind of a similar idea to the completion, which is the number of turns it takes to reach the winning condition. And again, for Sega, the number of turns increases quite dramatically as the board size grows, and then up to 2,500 is the limit that we set to the AI, so it doesn't play forever. So it quite quickly reaches that upper limit. Whereas for Karebga, it increases, but not quite as dramatic. But also looking at the tableau, it takes very few turns to play that. So that also might be an indication that at least the way that we put those rules on that board might not be a really good solution. Another thing that we did was, so we kind of wanted to explore, okay, even even though, so the conclusion from these are that Karuga seems like a more likely rule set that could be played on most of these board sizes, because it is completable for some of them, but also it takes fewer turns than Sega does, but also you know, you can see 1,500 turns is still a really long game. So we thought we might look at some more, look at it in a little bit more detail to see what is going on as gameplay is actually going on. So what we looked at here, in black, you see the total number of pieces on the board at each turn, whereas I think it's blue is player 1 and orange is player 2, and for both rule sets. So it kind of goes down with this in increasing size. And what we see really starts to happen, especially for the as you get bigger, is that you have all the pieces get placed on the board, and then you have long periods where there's not a lot of change in the number of pieces on the board. And this is better illustrated when you look at the percentage of the pieces that are on the board for each player. So you get situations where you have one player gaining an advantage and kind of maintaining that until the end of the game. And you have this going on for sometimes for hundreds, almost 1,000 turns, as the board gets bigger, where one player has been dominating the game for a long time, for considerably dominating, and it's continued, and that the AI is continuing to play. And this especially becomes more true as the boards get bigger. So because we don't think that people will play a game for hundreds and hundreds of turns where they are not going to win, and it's obvious they're not going to win, we think that this leads us to the conclusion that these larger boards probably do not fit well with those rules that we understand from the Roman sources. And we also kind of looked at some of the other games that we have in the database, because we do have games where the goal is to capture all of the pieces on the board that are on larger boards. And we kind of looked at kind of 10 by 10 as kind of really the cutoff where everything, especially for the Sega boards, seemed really to go on way too long. So we looked at other games that we know existed and that people played, and those large board capturing games had certain features that kind of speed up the gameplay. So some of them are enlarged chess variants, where you add more pieces that have more movement properties to help to speed up those games. Some of them have a fixed number of moves. So the Hawaiian game Konane, where the board is filled with pieces to begin, and every move has to be a capturing move. So that has a finite number of moves that are possible on that game. Some of them are drafts games or checkers games, where you only actually use half of the spaces on the board. So that's actually kind of a smaller board. And some of them are multiplayer games. So we think that the larger boards, based on what we know from the Roman sources and from what we can look at from the AIs, are probably, the larger boards are probably some other game. And Ulrich has already suggested this from other, just from other sources and things. But yeah, and we do know that the games from early medieval Northern Europe have large boards, are probably for Hnefatafel, which is a different game from Ludus Atroculorum. So yeah, so this was one way in which we're saying, using the AIs to say, okay, we have this corpus of archaeological material. How can we test what we know about the play of these games to say something about the archaeological evidence? So yeah, so that is that case study.